test the null hypothesis, the first thing we have to do is pull out the pertinent information that we're going to use in the test statistic formula. 30 correct looks like his sample mean, while the population mean is stated as 27. Population standard deviation is 11.6. Sample size was 100. So there's the important data that we're going to use in our test statistic. First thing you do is you state the null hypothesis. In this question, it says that the mean of the population is 27. State the alternative hypothesis. You notice that there's no symbol between the moon and 27. In this study, he's claiming that it's greater than 27. Let's go ahead and find that test statistic using this formula. Plug in known values. We're going to get a z-score of 259. So let's go ahead and find out what the z-score of 259 is. Let's double check on that. Using your z-table, you find a 2.5. You scroll all the way over until you see the 9 column. So it looks like 0.9952 is generated from a z-score of 2.59. Let's double check that again with Excel. Pick a cell, any cell, go to the formula bar, type in equal norms dist, the one with the S in the middle. That's going to give you the p-values for your z's, and ours is 2.59. Enter. But that is everything to the left of that, everything less than. So what we have to do is go up to the formula bar, type in 1 minus before all that norm dist stuff. That's going to give us the area to the right of it. So that is correct. So because it's a greater than problem, we need to go ahead and subtract that from 1. So we now have our p-value, okay? So let's go ahead and see what that does for you. I want to remind you of what a confidence interval is. Remember, a confidence interval, if you repeated the process many, many times, then the means should fall into that range 90% of the time, 95% of the time, whatever the level of confidence is. Remember, that's a confidence interval. And for our 0.0048, you can already tell that is not going to fall within this confidence interval mean. In fact, what it's saying is, because it's a greater than, it's only going to come out to be about that percent, that 0.0048 of the graph to the right of that number. So that's not very convincing. Step 4, let's see how it compares to the critical value, the cutoff value, commonly called alpha. And yeah, that critical is much bigger than that. So that's true. Then we make our decision. We reject the null. And it's party time again. Whoop, whoop, celebrate, celebrate. And that's all there is to it.